We're going to shift gears now and look at the predictions in terms of the probabilities. So let's get some data that we can look at here. Why don't we try, I don't know, let's try like the last few rows or something. Let's see what we get here. So, okay, this is kind of good because we have some, the top and bottom, we've got differences. Let's check the end, and yeah, we've got some definite differences here, all from the United States, so we don't have to worry about the countries going back. Okay, so we're going to look at the probabilities of these last five. Okay, so how do we get the probabilities? We have an operating model, and we can hit the dot, and we can look for it, and look at this, predict proba. So this is going to give us, so the predictions will give us 0 or 1, but the prediction of probabilities will give us the actual probabilities that they're 0s and 1. Let's do both so we can have clarity on this. Okay, so let's just look at the last 5 rows. So how do I get that using my x? Well, it's x what? I want to start with the -5th row and take all the rest, and I want all the columns. That's an ilog, so for index location. Okay? That is those 5 rows above. You can also use x.tail. And you can see what the predictions are. So we got a 1, 3 zeros, and then a 1. If I go to the end, you can see the last one is right. The first 2 are not. Okay, so this is interesting. Now let's check the probabilities of these models. So that was predict proba, short for probability, and we can put in the exact same input, right? The model's already been built, so when the model's already been built and you put this in there, let's be clear about what it does. It just takes this data as input to the model, right? Doesn't include this last one because this is our data frame. That's just the input. The model's been built, and so it doesn't care whether it's already been there or not. We just see that these are data points that are already there. Okay, well, let's check the probabilities now. And so this is interesting, right? So you can see that it looks like the probabilities are on the right side here as far as, is it a 1 or 0? Not very sure about the first one, which is actually incorrect. They're a little more sure about the second one, which is wrong. But look at the others. Is it the last 3 are all correct? And you can see they're all correct to high probabilities. So the reason why it's like it's different sided depending on whether it's a 0 or a 1. So if we look at the last row, okay, I mean, like, it's a model, okay, it's a mathematical model. So, but the way you would interpret it is that there's 99.4% probable that it's a 1, and they're correct. This one, 99.2% rounding probable that it's a 0, and it's correct. 96.2 probable it's a 0. Okay, pretty good probability, correct. Now this one is down to 80% probable that it's a 0, and recall they are wrong because it's a 1, and this one also, they're wrong. And this one is kind of 5643, right? It's kind of cool because it's showing one of those middle data points that it's not really sure. And so